Okay, this is the part that gets to what you just mentioned. We too are looking ahead to say, how do we do planetary protection with humans on a place like Mars? So I'm giving you information about the planetary protection workshop that we had. We're looking ahead at NASA on what do we need to go from the robotic exploration that we've done and do so well for science to human missions. So I'm presenting to you the background and context for this workshop, and I'll give you a bit about the logistics of the workshop that focus on three key areas. And in looking ahead, how we'll be continuing an incremental process towards developing eventual NASA procedural requirements for planetary protection. So where we are right now is the planetary protection requirements are very well established for robotic missions. And those go on with some problem, I suppose, but they are managed and done on Mars missions all the time. And so what we need as we look ahead is planetary protection requirements for human missions. We haven't done human missions beyond low Earth orbit since the Apollo program. The laws have changed, the technology's changed, our notion of understanding of what's up on Mars, the human microbiome, all have changed considerably. So we need to take COSPAR requirements, which come in under the Outer Space Treaty. They are, compliance is mandatory. Thou shalt not have any biological contamination of a sort that is harmful to either the forward contamination considerations or back contamination of Earth. And during a mission, we also need to think about crew health as well. So how do we translate planetary protection requirements under the Outer Space Treaty into something that makes sense for Mars? Also, I might say that in the Outer Space Treaty, the U.S. is a signatory. There's over 100 other nations that are signatories, and anything that applies to the government also applies to non-government entities. So this is a whole area where we have to work together to figure out how it will apply. So in 2012, the NASA's Planetary Protection Subcommittee recommended that we needed to move ahead and start to develop these requirements, and the Human Missions Operation Group and the Planetary Protection Office began working together. In 2013, they recognized we really can't go there in one big step. It's not possible. So we need to do a stepwise incremental approach in the form of a NASA policy instruction, an NPI. So regardless of which way we get, whether we go to asteroids first or the moon or Mars, we know that future human missions will have a lot of systems that are much more complex than robotic systems, from biological monitoring to thinking about decontamination or sterilization each time you go in and out. Spacesuit designs will probably be different. Drilling equipment to go into the subsurface, ISRU, what are the pathways and processes for contaminants to move around, and how do you handle samples, keep your habitat separate from your labs, all of those things. And there's well over 100 articles that have provided a lot of information, as well as a number of NASA and ESA workshops that were held early in the decade that give us a lot of information about what kind of systems are involved. In 2008, COSPAR put together a set of principles that do apply. They're not in the form of regulations, but principles. Safeguarding the Earth is the highest planetary protection priority, so returning anything is going to be an issue. Doesn't mean we don't have to worry about forward contamination, and we do obviously have to worry about astronauts' health, but safeguarding the Earth is the highest priority. Human-associated contaminants must be understood. We know that they will be there. We have symbionts with us. For every cell in your body, you have 10 times as many microbes. For landed missions, we know that they cannot be performed in entirely closed systems, and likewise, for landed missions, humans will be exposed to Martian materials. So how do we proceed in turning these into workable guidelines for proper environmental management and crew safety and all of that? So there are implementation guidelines that have been set, not requirements, but they say continuous monitoring is key to this. A quarantine capability will have to be built into the situation. Protocols will need to be set up for human missions and robotic aspects of missions, just as they are for robotic missions or Mars sample return. Neither robotic systems nor human activities can contaminate special regions. Now that's going to be an interesting one because special regions include ices, waters, places where Martian life might exist. So how can you do ISRU and drill? In the same way, think about using that material if you don't know if there's Martian life in it. Pristine samples that you would bring back for scientific purposes will be brought back the same way robotic samples are, fully contained and not released until there's a complete and rigorous review of an analysis in laboratories, equivalent of BSL-4 moon-suited labs on Earth. And there will be an onboard crew member who's assigned the responsibility for planetary protection. And just as all our other missions, we take a conservative approach on planetary protection. If you don't know, assume that there might be life there. So this procedural instructions approach is one that NASA is looking to identify and develop capabilities in order to monitor microbial communities. What are the pathways? What are the dissemination? If it gets outside, does it just die? That's great. Then we don't have to worry about it. We need to develop technologies that would minimize and mitigate contamination, and we need to understand what environmental processes on Mars might do to microbes that are outside. So yes, we will vent. If they all die, that's great. If they don't, where do they go? So we're taking that current information, we're adding it with information about suits and rovers and ISRU and all sorts of other things, and eventually we'll come up with sets of new requirements. And they're not doing it alone, we're doing in discussions with international community as well. So a workshop was held here in the end of March at NASA Ames that was sponsored by the Planetary Protection Office and the Human Missions folks. 85 people attended. We had 3 subgroup foci that were important on this: microbial and human health monitoring, technology and operations for contamination control, and natural transport of contaminants on the surface. Overall, the goals of the workshop were just to identify those knowledge gaps. Where do we need our research and technology development with respect to human missions to Mars? Can we gather and discuss information needed to help us move closer to identifying those gaps that would eventually need to be filled before we can do these requirements? Can we assess the types and levels of research that's underway and what more needs to be done? And how do we start to build that network of people that are technology and science to work together? So the first thing was to assess the state of knowledge and the gaps that exist. And the workshop addressed things in 3 prominent areas. The study area 1 looked at human health and microbial monitoring, looking at all sorts of consumables, microbiome research, crew quarantine, and such. Study area 2 looked at technology and operations for contamination control. What do we use already for contamination control of any sort? Obviously, the technology community is very well versed in this. We think about dust, for instance. The astronauts, if the biomedical community is concerned about dust, if it gets into an astronaut's lungs, that may not be good. So they're concerned about dust. The technology community says, you know, dust will mess up my instruments and the way they work. And planetary protection is concerned about dust because it's a potential dissemination source for any kinds of microbes. So as we work on dust, let's work together. So there's nobody starting from scratch. And study area 3 is looking more at the Mars environment and looking at how do we understand microbial dispersion and mortality and such on the planet. So there were 5 guiding subgroup questions. After hearing plenary sessions, then we broke into groups. What planetary protection related research and technology development areas are critical for moving ahead in your area? What work is already underway? Have we looked at both nominal and off-nominal situations? And if not, identify the gaps. Are there existing options for mitigating contamination that are acceptable, that are already in use, or that can be adaptable? And are there significant stumbling blocks, aside from funding, of course? And the objective was to identify these research needs and contribute towards meeting the planetary protection requirements eventually. So the literature survey has been completed. It's a thorough look at all of the nominal requirements that have been identified for planetary protection with an identification of more specific functional requirements that the technology and engineering community would need. The workshop has been completed. The technical report is in preparation, and there's 3 journal articles that are in preparation for a special issue of advances in space research that will focus entirely on planetary protection. One will be this literature survey, including a systems engineering approach, another article on the workshop itself, and a third looking at that engineering approach. So as we look ahead, we're still moving from this first step towards the requirements, and already we've seen some progress by working together with the engineering community. We've already got some work where engineers have said, gee, do we even know how microbes get disseminated from space station? So there's work on developing a prototype tool so that when the astronauts go outside for spacewalks, we can compare what are the microbes inside a vent, say over a kitchen area or a bathroom or a sleeping area, and what's getting out. Are they alive? Are they not? Are they mutating? We don't know. So already they've been developing materials to test and to perhaps do some of those tests with spacesuits and on space station in the next coming year. And there's also some look at DNA sequencing using much more up-to-date methods that would be real-time as opposed to growing things in a laboratory. And some of those are being done in situations with field analog sites. How do microbes disseminate from a Humvee, the equivalent of a rover? When you build a habitat, how long does it take before you start finding microbes from human-associated microbes outside? Do they persist or not? If they don't on Earth, we probably don't need to worry about them outside. So all of this will go forward, and we're hoping this workshop will identify research that can be attended to in the coming years, both for the science side of things as well as the technology. So questions, and just keep your eyes tuned for, or keep your eyes peeled for the various workshops and articles, reports that will be coming out.
Thank you, Margaret. We have time for maybe one question. Anyone has it?
It's interesting that we don't know of any microbes that can survive in the peroxides and UV that you find on the surface, but subsurface it is a concern. But we do know that we're receiving about 1/2 ton of material from Mars. Now, most of that is going to be too small to be able to keep a viable, but some of that, almost definitely a fair amount of that could be carrying. So at least once a decade, we can easily be receiving microbes from Mars. And it's like 100 pounds or something is going the other direction.
You're speaking of the natural influx to Earth,
yeah.
Right?
I'm convinced that we're descendants of Martian microbes.
It's possible. You're absolutely right. That's a hypothesis, and it doesn't take convincing or opinion. It takes facts. And so you're right. When we look at what's coming in the natural influx, it comes in, but when we're up on Mars, it's real time, it's then. And so we need the data to show that. And honestly, if scientifically we can show that it's not an issue because they all die, that's great. Planetary protection goes away. But the Outer Space Treaty isn't going to go away, and we can't just say we don't like it, it costs too much.